Audio recording for this meeting has begun.
Great to see some folks on already today. A few reminders before we get started. My name is Molly Marin. I'm the webinar coordinator for the New York State RTI Technical Assistance Center. All upcoming professional development offerings are listed on our webpage at nysrti.org. A copy of today's PowerPoint and handouts are available on our webpage. I posted the link in the chat box because it is rather long and it'll take you right to it. Also, we did email out 2 handouts to participants yesterday. If you didn't get those in your email, they're also on our webpage. During today's presentation, please use the chat box for any questions or comments that you may have. And at the end of today's presentation, we'll post a link to a brief evaluation. If you could please take a few minutes to complete that, we do appreciate that feedback. We are very pleased to have back with us Dr. George Bash, who will present our 3rd webinar in our Strand 16, Response to Intervention, a Multi-Tiered System of Support series. Today's topic is integrating the database problem-solving process, RTI, into a MTSS. Dr. George Bash is a professor and director of the Institute for School Reform at the University of South Florida and director of the Florida Statewide Problem-Solving RTI project for the Florida Department of Education. And at this time, it's my pleasure to welcome back Dr. Bash.
Thanks, Molly, and welcome, everyone. I was asking Molly how the weather is in Buffalo. I'm here in Tampa, Florida, where it's actually been in the low 50s in the morning. So we're all down here wearing winter clothing, which I'm sure is humorous to you that in the 50s we need to be warmed up, but we're kind of wussies down here with cold weather. So today we're going to talk about problem solving and how that fits into MTSS, but more importantly, how it really fits into improving instructional outcomes for students. I'm going to get started here with just a brief, I recognize, by the way, I recognize a bunch of the names on here, so those of you who are returning participants, thanks a lot. It's nice to, if I haven't met you, it's still nice to see names I'm familiar with. The goals of this webinar have been to understanding the key components of MTSS, how it relates to the Common Core Learning Standards, how to integrate database problem solving into it, that's our focus today, aligning instruction and interventions with the standards, how to integrate academic and behavior, expectations for kids, where do students with disabilities fit into this, having some good courageous conversations, reflecting, celebrating, reverberating, most importantly breathing, and getting fired up about this stuff. Thanks again for joining. Last time we talked about integrating academic and behavior goals, aligning MTSS with the Common Core Learning Standards, unpacking those standards, identifying skills to be the focus of instruction and problem solving, and using universal design for learning. So kind of the connector this session is once we've identified areas that students individually, groups, grade levels are struggling with, how do we use problem solving to figure out what to do? So this week we're going to identify the steps and activities, and in the problem-solving process we're going to apply it to a case study, a high school case study, and how to use the problem-solving fidelity checklist to ensure fidelity of implementation. You should have the checklist and a couple of the other things that we're going to refer to, but before we get started with the topic, with the content, Molly, if you could put up that that little survey so we can see who's here. If you'll complete the survey, that reflects what you do in your school or district. Well, that's a nice spread. Interventionists, coaches, math, literacy, special ed, district administrator. That's awesome. Thanks for coming. I'll take into consideration the different roles you have and make comments as we go along the process. Excellent. Okay. Thanks, Molly, if we can ditch that. So today, what we're really looking at is the problem-solving process. If you've been on the webinar so far, you know that there are 6 components to MTSS: leadership, the multiple tiers, problem-solving, how do we use data, communication and collaboration, and then capacity building. Problem-solving is really the engine that drives instruction and intervention. I want to make a statement up front that we only use problem-solving when we're not sure that we know what to do. If we know what to do, we should just do it. The good thing about using database decision-making is that if we've made a mistake or we selected the wrong intervention or the wrong instruction and we're collecting student data, then the data will let us know that our choice was not necessarily the best one, and we can go back and have at it again. I have this level of implementation to show you that this process of this 4-step process we're going to talk about today can be applied to the student level, and I'm sure that many, if not all of you, have been applying some kind of problem-solving process when you're trying to problem-solve individual students. But with MTSS, as we've said in the previous webinars, our goal is to improve the impact of core instruction first. Then we'll look at improving supplemental instruction and then intensive instruction. So we may have large groups of students who are experiencing the same issue. We may have a classroom of them. We may have a grade level or a department at a high school. The school level, it may be low overall percentage of students being proficient. And at the district level, we can use it to deal with issues that are common across the schools. And a district level problem solving would be the appropriate level to then apply the solutions or interventions to all of the schools in the district. So that could be an attendance problem. It could be a suspension problem. It could be, I'm going to show you a graph today, it could be a content area at a grade level across all of the schools. So you always want to problem solve at the level that the solutions are going to have the greatest impact. So we'll talk about that as we go through our work today. So the problem-solving process has 4 steps to it. There are fancy names for these steps, like problem identification, problem analysis, etc. I choose not to use those. Problem-solving is, at one level, common sense. At another level, it's very scientifically based. But I want to keep it at the common sense level so that it will have appeal and attraction for the greatest number of people. So there are 4 steps in the problem-solving process. And for me, there are 4 questions. What do we want the students to know, understand, and do? What's the goal? Second is, why aren't they doing it? Third is, what are we going to do about it? And the 4th one is, did it work? So when I was principal and district administrator, and in particular a building principal, all of us thought this way, whether we were dealing with an individual student, a small group of students, a large number of students. When we were trying to improve instruction, behavior supports, etc., we simply asked 4 questions. What do we want them to know, understand, and do? Now that's very different than what is the referral problem. In the schools I work in, our referral forms for problem solving or student support, we don't use the term problem. We really don't want to focus on the problem. We want to focus on the solution. So we've eliminated that referral problem kind of terminology completely. So once again, what do we want them to know, understand, and do? For academics, that's your Common Core learning standards. For behavior, it's the school, classroom, community behavioral expectations. Why are they not doing it? Answering this question, we're getting at what is the root cause of it, right? Well, we have to have some structure to that, so we're going to talk about what that structure looks like today. Implementing the plan should not be people sitting around wondering what to do. If you analyze the goal and why they're not attaining it well, the intervention or the solution is going to be staring you in the face. We're going to see that today. And then how do you evaluate if it works? That really is linked to that step one, identifying the goal. So let's take a look at it. Each of these steps in the problem-solving process has activities that you have to do. We're going to go through these activities one step at a time, so I'm not going to break them down here, but on your, you should have something called Tier 3 problem-solving checklist and a rubric to go with it. If you can get that out or download it or whatever, however you can make it visible to yourself, you will notice that that is a checklist that you would use at a meeting just to be sure that you went through all the steps and did each of the steps correctly. So that checklist is broken down into the four steps and the activities that go along with it. So I'll be referencing that checklist as we go through each of these steps. So step one, setting the benchmark, determining whose issue it is, establishing rate of progress necessary to attain the goal. Let's see what that looks like. So the first thing that we have to look at in step one is what is it we want students to know, understand, and do? And in this case, this is just a generic graph. So that in this case, whatever we want them to know, understand, and do is represented by the blue line. And it's 110 of something. It could be words correct per minute. It could be days of attendance. It doesn't matter in this case. It's the goal. It's the benchmark. The second thing is, what is the current level of the student or the student's performance? In this case, the student is like at 28 or 30. They're supposed to be at 110. So here's something for you to write down. Anytime the group, the individual or the group that you're concerned with, that their performance is more than 2 times away from the benchmark, that's an urgent problem. So in this case, let's say that this student or students, that their current level of performance is 30. 2 times that is 60. You see that that is still way short of the goal. We would have to go almost 4 times their current level of performance to catch them up. So anytime that you have to go 2 times or more, that's a very significant issue. So you can see that this, let's just say it's an individual student. This student is way far below the benchmark. We call that the intensity of the problem. How intense is it? How far away are they? The farther away they are, the more intense it actually is. The next thing we want to look at, so we have what we want them to do. They will want them to do 110 of something. We have the benchmark. So the current level of performance is 30. The desired level of performance is 110. The next thing we want to look at is where's the peer group performing for this group of students? So in this case, the peers are above the benchmark. Well, one of the things that you can do with this graph is to make an assumption about whether or not the instruction in this particular area is effective or not. Now, if the entire peer group is at or above the benchmark, and it's only one or a few students way down below it, then you have evidence that some pretty effective instruction is going on for whatever it is this goal is. So in the question here of whose issue is this, it's not the peer groups, it's the student. So it would be okay to problem solve the student here, if you go back to that first level on that rubric we saw a few minutes ago. Well, what about this next one? whose issue is it? Is it just that student's, or is it the entire peer group? So what should be the unit of our problem solving here? Just that student, or should we also include all of the peers? Type your answer into the chat box. Would you problem solve just the student, or would you want to problem solve the peers as well? What are your thoughts? Great, thanks for responding. Awesome. So you have the peers and the student. So I guess for me, if the student is kind of embedded with the peers, I would probably, just for time savings, problem solve the peers first and see what happens then to the one student you were concerned about. And by the way, teachers are always more willing to do interventions for a group of kids than just a single student. So there's some benefit there to acceptability in doing those interventions. Now I'm going to make it more difficult for you. I want you to do the same thing. I want you to type in your answer, and you could say student, peers, peers first, then student, student first, then peers. What would we do if this is what it looked like? Awesome. So once again, looking at this from a time management, effective use of time approach, clearly, even though the peers are halfway above the student to the benchmark, they're considerably below the benchmark. They're not quite on average there. If you look at the average, it's probably about 70, the middle. They're not quite 2 times, but they're pretty close. So I think I would start off with interventions for the peers, see how that student responds, but most likely, and one or more of you answered it this way, that student is going to need additional supports. If it's behavior, it's always of great advantage to work with that peer group either in conjunction with the student or first, because with behavior, students are not likely to outrun their peers. There's too much peer pressure not to be better than them. So in this case, I would probably do both with the understanding that that student was going to need some additional supports, but I would probably lead with the peers. There's no right or wrong answers here. The point that I wanted to make is that, and I'm going to go back here to that previous table, and I know this is slow, but if we have these different levels of analysis at the same time, you really do have to say, what's going to be the focus of our problem solving? And in the first example, it was clearly the student, no question. Don't mess with the peers. Student is very different. That student's going to need something very different. In this case, I can't tell the difference. I don't know whose issue it is because the peers and the students are at the same level. And by the way, when we're looking at special ed decisions and referrals, particularly for students with learning disabilities or behavioral disabilities, if we can't separate out a student from a whole peer group, we'll have a very hard time saying that the student has a disability and no one else does when they're in fact performing at the same level. So I'm going to give you a little example that we're going to work with here today. So for step one, and this is a high school example, it's a group of students, 27 to be exact, and the goal is to pass algebra in the 9th grade. Well, there are 220 students in 9th grade at this school. 193 are passing and 27 are not. So if we take a look at effective instruction being defined as whether or not 75 to 80% of a group is passing, being proficient with just Tier 1 instruction, clearly this 9th grade high school algebra sections, effective instruction is going on because we only have about 10%, maybe 12% of the students who are not passing. So between 85 and 90% of the students are passing, and that's a definition of effective instruction. But it doesn't matter if you're one of the 27 students or their parents, right? You want to be passing. So we have 27 students that we have to focus on. We don't want any of them failing. So currently, 27 students are failing. Our benchmark level is 0. We want them all passing within 9 weeks. So one of the things we do in problem solving is we establish how many students per week have to improve or meet the goal in order for us to say that our interventions are effective. So if we have 27 students who are the target of our work, and we have 9 weeks to get it done in, we have to move 3 students a week to a passing level. In the high schools we work with, we give students report cards for the targeted students every week saying that based upon this week's work, would you be passing or not? That way we have a progress monitoring tool for our intervention evaluation. So we'd create a graph. This would be our aim line. For those of you, and I'm sure many of you are familiar with aim lines, that's just the line that we have to stay on to reach the goal. So we're starting out the first week with 3 students improving, and by the 9th week we'd be to 27 students. We would then actually plot on here every week how many students hit the aim line. If that number wasn't hitting the aim line, we would, after probably no more than 2 weeks, we would go back and look at our intervention and re-look at this so that we wouldn't go too very far before we had determined that the effectiveness of our intervention wasn't going to enable us to achieve the goal. So I'm just going to stop for a few seconds here. Type in if you have any questions about that first step of problem solving. It's what do we want them to know, understand, and do? What's their current level? What's the desired level? We do a check with the peer groups to find out whose issue is it. And then we set a timeline for achieving that goal. In this case, 27 kids in 9 weeks, 3 kids a week. So I see somebody's typing, so I'll wait till. Good question, Deborah. What size group is suggested to make these gains? This is a high school. There are, I think, 10 sections of algebra, and I think there are 3 or 4 teachers, because those math teachers not only teach algebra, they teach other stuff. So the real question is how many students are in each of these teachers' class? Sometimes we do entire school problem solving. So the size doesn't matter. It really is a particular issue with what the problem is. I worked in a high school a few years ago where there were about 900 kids, and 250 of them had GPAs below 2.0. And we did problem solving for all 250 of those, but we used the entire year for the intervention, all 10 months. So what we had to do was to improve about 25 kids per month, which boiled down to about 6 kids per week, and that was doable. So if you have a longer time period, you can have a larger size, if that makes sense. Good question, thanks. Okay, step 2, the root cause. So then the question is, why are these 27 students unable to pass math? Problem analysis is very structured with us. We look at answering the why in 4 areas. What is it about the instruction? What is it about the curriculum? What is it about the environment? That could be the classroom, the school, the home, the community. And what is it about the learner that would help us understand why they're unable to pass math? And we collect data to answer those questions using a method we call RIOT. Review what information we have, interview people, students, teachers, observe, and collect assessment data, whether that would be group assessment data, individual assessment data. So it is a 2-step process. First, we develop reasons or hypotheses, root causes, that are in 1 or more of those 4 areas. And then we say, now how are we going to evaluate whether that's true or not? So we're going to play this out in a case study because I think it's a lot easier to do that rather than just some academic exercise. So here's our entry statement. The desired behavior is not occurring, so 27 students are not passing math. That's the desired behavior because. Let's say that this is a student who is starting fights with other kids. So the desired behavior, remember, we don't focus on the problem. We say what we want students to know, understand, and do. So what we want this student to do is walk away, use words, ask for help. So the student is not walking away, using words, asking for help, because. And I hope you see here that if we problem solve the reason they're not doing the desired behavior, it's a very different intervention than if we're trying to stop something we don't like. Stopping things doesn't have any long-term sustainability. We want to increase the capacity of students and staff to maintain the desired behavior. So I just went through that. What we tend to do for Tier 1 is, and I don't know what the why some things are missing here, but that's okay. For Tier 1, if we're looking at an entire classroom, groups of students, we look primarily at instruction, curriculum, and the environment. Because if something is affecting large groups of kids in the same way, it's probably not a student-specific issue. It's something about that relationship between the student and the instruction, curriculum, and the environment. If we're looking at supplemental and intensive instruction, Tier 2 and Tier 3, we pull in the learner. More so in Tier 3 than in Tier 2. We'll talk a little bit about that. So that means we begin using diagnostic assessments with learner. If you remember from our time about talking about the multi-tiers, that for kids who are getting Tier 2 services, we problem solve the issue, not individual kids. Once we move to Tier 3, then we have to start looking at student characteristics. So instruction is anything about how the curriculum is delivered. I'll give you some examples. The curriculum is the what is taught. Now think about your teacher manuals. Curriculum involves scope and sequence, what is taught when, pacing charts. The environment is where the instruction takes place, and that could be the home, it could be the classroom, it could be tier 2, it could be tier 3, it could be a grade level, it could be subject area, a lab. The environment can be broken down in a number of ways. It's easiest if we think about it in terms of classroom, school level, home, and community. The learner is anything that is hardwired in the kid. So that would be skills the kid has or doesn't have, biological factors that he has or doesn't have, things like memory, concentration, attention, attitudes, beliefs, skills, anything that's inside the kid. You have this as a handout, a downloadable, and you can look at it at your leisure. But this ISIL by Riot matrix breaks down instruction, curriculum, environment, and learner. It defines the domain. It then gives you possible areas of hypotheses for that domain. And then it gives you different assessment methods to collect data around some of those hypotheses. So if you're really interested in this, I would encourage you to look through it. And this is just a starter copy. You certainly could add your own stuff to that. So I'm going to give you one example here, then I'm going to ask you for participation. So expectations, home, school, community for performance are low. That hypothesis is an environment hypothesis. Let's take a look at the top one. The schedule does not provide time or opportunity for practice and instruction necessary to catch up. Is that instruction, curriculum, environment, or the learner? Put your answer in there. The schedule does not provide time, opportunity for practice and instruction to catch up. Okay, let's see. It's environment. I understand the instruction responses, but a schedule is probably more of something that reflects the environment of the classroom or the school. So that's why it's under that category. Okay, let's look at the next one. The instructional strategies do not emphasize explicit instruction, content enhancement routines, sufficient feedback, guided instruction, or differentiation. What do you think about that one? Instruction, curriculum, environment, or the learner? Yeah, I think that one's pretty unanimous. What about the last one? The pacing is too fast. Doesn't provide for sufficient student engagement. Materials are not aligned with the standards, and instructional sequences are not sufficiently explicit and are inconsistent across teachers. Yeah. Sure, good job. There's a little bit of instruction stuff in there, but pacing, alignment with standards is probably more so curriculum. So you guys did a good job. All right, so let's get into this. 27 students are off track in 9th grade due to course failures. The mathematics content area resulted in the greatest percent of course failures for 9th grade students. This is true for that high school. So the problem is occurring because, and in this case, we use Stickies in these meetings. we will do a little sort. So we'll have either a poster board or something on the table with instruction, curriculum, environment, learner, and people generate hypotheses and then stick them up. And that way we can see what people feel is the primary, the focus of the areas of the root causes. It's kind of a fun activity. So let's see what this school came up with. They came up with 3 hypotheses. These kids are not passing math because the first one was because of excessive absences during math class. So students are not present. Clearly that is an environment issue, and you would then predict, if this hypothesis were true, you would predict that when students attend class at a much higher rate, then they will receive passing grades. So the prediction is just, if the hypothesis were true, what would we expect to see? Another hypothesis. They're not passing math because not enough time is allocated for the most effective instructional practices. If more time was spent during class time using instructional practices that had high rates of student engagement, modeled, guided, then student performance would improve. So one of the things that I want to point out here is that we identify instructional practices as not just evidence-based instructional practices for the learning goal or the standard being taught. But instructional practices for us have to have high levels of, effective ones, have to have high levels of student engagement. Otherwise, we have the Motel 6 instructional practice, lights on, nobody's home, right? The teacher is using awesome instructional practices, but the kids are simply not engaged. So that's why we have that relationship. Let's look at this one. They are not passing math because students who are failing complete less than 50% of their classwork and their homework. So when struggling students, D or F, complete more than 80% of their homework and classwork, then they will improve at least 1 letter grade. When struggling students complete 50% or less, they do not improve at least 1 letter grade. So there's a saying that a good friend of mine named Anita Archer says, that preparation is for an event, like a test. Practice is for life changes. In other words, things that sustain. So we're not looking at preparation here. We're looking at practice. And we all know that practice, appropriate practice, is necessary to strengthen behavior. So these were the 3 that this team decided to select from that sort, from the Stickies, as their first approach, as their first priorities for problem solving. So now we have to say, for those hypotheses, what kind of data are we going to collect that we can validate the hypotheses with? So let's take a look at what they did. And these are and/ors, there's not one or the other. So for hypothesis 1, they're not passing because of excessive absences. When students attend class at a much higher rate, then they'll receive passing grades. So they were going to review existing data, gradebook data, to compare the grade distributions of students attending 95% of the time or better with those students attending less than 95% of the time. Because if your prediction is that students that attend do well and students that don't do poorly, you already have that data in your gradebook. You have your student performance data and you have your attendance data. So for the second hypothesis, if more time was spent with instructional practices that had student engagement, I'm going to give you the answer here. I have a slide out of order. I apologize for that. So for that first hypothesis, the data showed that the average rate of attendance for students receiving A through C grades is 96% of the time. The average rate of attendance for students receiving F grades is 94% of the time. So there's no difference in attendance rates, but there's a big difference in grades. So it's not grades, it's not attendance that is affecting those grades. The students who are getting Fs are coming just as often as the students who are getting A through C. So you'll see we'll eliminate that hypothesis. So the answer to it is no, it's not validated, and we ditch it. Let's take the second hypothesis. We want to observe. We're going to use observation data. We're going to collect data during walkthroughs or classroom observations to assess the type of instruction that the teacher is using and what percent of the time they're using it. We just do that with a timer. And whether students are engaged or not. There are multiple observation forms available that assess the type of instruction, the amount of time, and student engagement simultaneously. And principals are often familiar with those observation protocols. So here are the data that were collected through the observation of the instruction. So 27% of the time, students were engaged in independent practice. That's the orange. 24% of the time, explicit instruction was being used. 13% of the time, modeled instruction was being used. 13% of the time, guided practice with support was being used. With teacher support, 6% of the time, guidance with peer support, guided practice with peer support was being used. So explicit instruction is that stand and deliver type of stuff. Modeled instruction would be the I do, we do, you do, with guided practice and peer support. So now we know what percent of the time different instructional practices are being used. Now let's take a look at the relationship between those instructional practices and student engagement. So let's start off with explicit instruction. Explicit instruction was done 27% of the time, so almost a third of the time, with about half of the students engaged. Let's jump to guided practice with peer support. We see that guided practice with peer support is used only 6% of the time, yet it has 80% of the students engaged. If we look at guided practice with teacher support, that has the highest level of student engagement at almost 90%, and modeled instruction is at 86%. So if we go back and take a look at modeled instruction, 13%, guided practice with teacher support, 13%, and guided practice with peer support, 29% of the time, instructional practices are being used that have the highest levels of student engagement. And 81% of the time, instructional practices are being used with the lowest level of student engagement. So there is a strong relationship here between instructional practices and student engagement. Unfortunately, the instructional practices with the highest levels of student engagement are being used least often. So, is this hypothesis validated? You guys don't have to talk at the end of the day. I'm making a feeble attempt at it. Yes, the types and times of instructional strategies vary significantly and are strongly related to student engagement. We're going to come back to that here in a moment. The last one is what is the relationship between students who pass and whether or not they do classwork and homework. So we're going to review data. We're going to review the work, the accuracy of the work that they complete, but we're also and their percent of completion. But we're also going to interview students to find out why they do and don't complete their work. So here is, so in this case, we're going to be using review and interview. So here are survey results from students surveying their productivity. So the first question is, about how often do you not complete your classwork? The first two questions are on classwork. The second two questions are on homework. So the students always complete their homework, or 54% of the students always complete their homework, meaning 46% of them don't. So it's about halvesies. When they don't complete it, about 17% or 12% don't complete it 1 to 3 times a semester. 17 don't complete it 1 to 3 times a month, and 1 to 3 times a week is about 11%. So we have almost 30% of the students not completing their homework between 1 to 3 times a week and 1 to 3 times a month. Well, 3 up to 3 times a week, that's what, 60% of the time. Up to 3 times a month, with 20 days in the school month, that's around 20% of the time. That's quite a bit for almost 30% of the students. And we said, why do you not complete your classwork? 9% says it doesn't matter. He or she's going to fail anyway. 40%, 39% say the classwork is boring. 31% said I need my teacher to watch my work and correct my mistakes. 23%, I need my teacher to show me more. And 49% said I don't understand how to do it. So 54% of the kids are saying I need modeled and guided practice. Interestingly, that also paralleled the observation data, right? Now the same question about homework. I always complete my homework, less than 50%, 1 to 3 times a semester, a month, and a week. In this case, we have 32% of the 32% of the kids are not doing it anywhere between 20 and 30% of the time. And why? 43% I do it without trouble. 3% says no one's checking it. I didn't bring home the materials the night before. I didn't write down the assignment. I don't have help to do it, 43%, because they could put multiple reasons here. And 66% said I don't understand how to do it, which is the highest rating for homework. It's also the highest rating for classwork. So what we see there is that there are some parallels with students' answers with the classroom observations. Now, a point I want to make here is I don't visit very many places where when you want to know why students are struggling with something, I don't know very many places that survey them. So that we do that fairly frequently, and they really do help us understand some of those root causes. So that might be something that you consider. So now we looked at the data. For the first half of the first semester, the first half of the first grading period, for those students doing less than 50% of their work, they got a D or F grade. For those students who were getting those Ds and F grades in the second half of the grading period, where we put some interventions in to increase work done, if they completed 80% or more of their work, they moved up 1 letter grade at least. For those of doing 80% or more of their work, nobody had weekly failing grades. But for those students who had the Ds or Fs the first half of the first grading period and still were not up to that 80%, they were unable to move out of their grade range. So clearly, the amount of work you complete in this high school's ninth grade algebra is strongly related to you passing the class. So if we then take a look at this, we have validated two hypotheses. We have validated that there's a relationship between the type of instruction, student engagement, and student performance. So if we know that teachers are spending 2/3 of their time using instructional practices that have low levels of student engagement, what's the intervention? Type in your answer. If this is true, then this is not rocket science. What does the intervention need to be? Yes. So start spending more time using instructional strategies that students will engage. Now, if some of you are classroom teachers here, if you had this information, that would be an easy switch for you, because I don't want to go all the way back in the slides, but if you go all the way back, clearly those teachers have the skills to do the modeling, the guided practice, because they're already doing it. So this is not throwing teachers under the bus. This is giving teachers more strategic information on how to use their instructional practices to improve student outcomes. The fourth hypothesis was also validated, that if we can increase the amount of classwork and homework that students do, we already have evidence through this problem-solving process that those students will elevate their grade by at least one letter grade. So on the surface here, what's the obvious intervention? What do we need to increase? Sure. So if there's a relationship between the amount of homework and classwork that students are completing and their grade, and we have a bunch of students completing less than 50% of it, what is on the surface the intervention need to be? Sure, increase rates of completion of homework and classwork, as numbers of you had cited. Now I'm going to go back here for a moment. In this case, we asked the students information to help us understand why they weren't completing it. So now we know what the intervention, we can say with certainty that if we get students to increase their classwork and homework to an 80% level or higher, they will be able to raise a grade. But now the question is, how do we get that to happen? So if we go back and look at the student survey data, what we see them saying, large numbers of them, are saying that I need more modeling and I need more guided practice and feedback during class because I don't understand how to do it. And for not completing homework, it's because I don't have help to do it and I don't understand how to do it. So there's a relationship here between our modifying those instructional practices to have more modeling, more guided, and more feedback, because those are the reasons that students cite for not being able to do their homework, because they don't have the help at home. So if they understand it better, get more practice and more feedback in class, that will address the reasons why they're not able to do their homework, at least some of them. And the same thing is true for classwork. If the teachers guide more, develop more, and give more corrective feedback, then the students will have more skills to complete their classwork. So in this case, we validated that a root cause was not enough productivity. But then we had to go back into the survey to find out what to do about it. So, and I'm going to jump through this quickly. Once we get into doing interventions, we really have to have a plan. And the plan, it doesn't have to be complicated, but it has to be put on paper or on a computer. And these are the 5 elements that have to be there. What are we going to do? We are going to increase the amount of time that we are doing modeling, guided with teacher support, guided with peer support. Who is going to do that? The classroom teachers with their algebra, professional learning, community support. When will it be implemented? We're going to start immediately, and we're going to implement it for 4 weeks, which is half of the first grading period. What data will be used to will be collected to monitor it. We're going to do those weekly report cards. So in this case, it will be chapter tests, common assessments. We could also continue some observations to see if that student engagement is holding up. And how often will the data be reviewed? At least initially, this group decided to do it each week, at least for the 4 weeks. We wouldn't want to go 4 weeks to find out it wasn't working. So how do we judge, is it working? Go all the way back to that beginning of the PowerPoint, and we have an aim line. 3 students a week have to move out of an F range and into D or above. So each week, with those weekly report cards, if we have 3, we just plot that on that graph. And as long as we're staying close to that aim line, the intervention's working on our timeline. If it's not, then we're going to know it in a couple of weeks, and we need to come back and look at the problem-solving process again. Intervention support is really important whenever we're doing targeted interventions, and it's part of this step 3. So before we launch into this, we're going to ask our algebra teachers, what support do you need? That could be having peers come in and observe to be sure that I'm increasing those high engagement instructional strategies. The PLC, professional learning community, might support the teachers who are doing this with strategies to provide feedback for students. The principal could provide support to give that PLC additional time and come in and do some of the observations to share data with the teacher. You want to have somebody checking with these teachers at least weekly to answer the question, how is it going? For certain interventions, you would want to track that they're actually being implemented. For this one, since it is an all-classroom intervention, we probably wouldn't use this form. But for Tier 2 and Tier 3, we keep track of the students, what interventions they're getting, what the focus of it is, and for how long. So you'll see on the left-hand side the student name, teacher name, and then for each day of the week there's T, P, and F. T is how much time, P is what is the practice of the program, and F is what is the focus of it. So at the elementary level, it might be 30 minutes a day of Wilson's Foundations, focusing on fluency, or it could be vocabulary. So we'd write 30 WF for fluency. We have this on computers, or you can simply fill in the data for the first student, and if everybody got it, just put a straight line down through the column. You don't have to write it down for all 6 or 8 students or what have you. But this is a tracking form to document that they got it. All right, let's talk for a few minutes about how do we evaluate response to instruction and intervention. This step 4, did it work? I gave you an embedded example with an aim line and then that trend, or 3 students a week making it. But let me back up and give you some examples of how we ask that question for entire grade levels in a district. How do we look at individual students? So the first thing we have to do is have decision rules. What constitutes sufficient practice? And we have to have decision rules for what do we do when we have a certain kind of response? What do we do for positive? What do we do for poor? So let's define these. And every district should have guidelines so that the response to intervention decision is consistent across all the schools in the district. So a positive response, the gap is closing. We can extrapolate a point at which the students will achieve the goal and or the level of risk is lowering. So a graph might look like this. So that yellow line you see, that was that blue line before. The students were continuing to fail. But each week, more and more students comes closer to the line. The gap is closing. And it's very clear that it's closing. This is an individual student graph for fluency. The student was way below expectation. You see that below the white box, way below it. Some Tier 2 interventions were done, but that line it increased, but it didn't increase enough. So those interventions were revised, and now the student is staying on that aim line and is going to achieve that last benchmark box by the end of the year. You could see that initial line, if you extrapolated it and carried it out, that the student would not have come anywhere close. If the longer we wait to make the decision about whether something is working, the less time we have to catch up if it's not. So that's why progress monitoring is so important. It lets us know as soon as possible, and that gives us the most time remaining to catch a student up. Questionable response, there's improvement. And typically, the student improves, but not enough to close the gap. So it looks something like this. Definite improvement, but that same gap is happening. Here would be an example for an individual student. So you see that student started out at 47 words correct per minute, has increased to 62, but it's below the aim line. The dotted line is that aim line, which is the same line that we developed that blue line for our high school kids. So each week, if we put how many kids were getting above F, you will see that for the first couple of weeks, we were doing okay, but then it started falling off. And if we extrapolate that line out to that black dotted line, you'll see that we're not going to make it. So we have to stop and make revisions to the intervention. And a poor response is the gap continues to widen with no change in rate. So that's what it would look like. The student, you can project from those first 5 data points on the left and take that line and project it out, and the rate of progress is remaining the same. There's no change in the slope of the line. The student is just keeping on, keeping on. So in this case, here's an example of a student that improves, goes from 18 to 31, but the slope of that line, the rate of the progress, just doesn't change. So that intervention is not working, even though the student is improving. And the problem here is that when the rate a student has to improve, the aim line, is steeper than the student's improvement line, then we have a very dangerous situation, because the student could be improving, but will end up farther behind because the rate of improvement isn't equal to the rate of the growth of expectations. So that's why we always want to have that aim line. What do the standards, where do the standards say we should be? Because if we're just tracking student growth, we could end up with having a student farther behind at the end of the year, even with improvement, than at the beginning of the year, and this graph shows that. Let's take a look at a whole district example here. This is third grade for a pretty large district for fall, winter, and spring benchmarking data. And this is reading for the entire district. So in the fall, 53% of the kids were proficient, 28% of the kids had a moderate level of risk, and let's see, 29% of the kids. So that makes, so I can't read the little number, but it's whatever the red number is, it's 53 and 26, 79. So 21% of the kids were at high risk. Now, look at winter and look at spring. If we were trying to improve, our goal was to problem solve in the fall to significantly improve the impact of our third grade reading curriculum on student outcomes. Are we achieving our goal or moving farther away from it? Type in what your reflections are on those data when our goal was to improve the performance of kids with the third grade reading curriculum we selected. Is it working? Did it work? No, you're right. You're all right. It didn't. My recommendation to parents in this school district is if your kid's starting there in the fall and they're in the green, they're proficient, get them out of there as soon as you can, because their probability of staying in the green is going to go down because the green is shrinking. So my question for this district was, by the winter benchmark, you knew that this program, this curriculum wasn't working. Obviously, not much was done between January and May to make a difference. So that's what is called admiring the data, as opposed to doing something about it. This district had 10% more of their kids in 3 months move to moderate and high risk, 53% proficient in the fall, 43% in the winter. They lost 10% of their kids and basically weren't able to turn it around. So that is a response to instruction at a district level. Let's look at it now at a grade level. And this is for grade 2. These are data from last year. These are STAR data, Renaissance Learning, STAR Reading, STAR Math. And this is reading, I believe. So what we see here is what percent of the kids are proficient, what percent of them are on watch, what percent of them are in need of intervention, and what percent of them are in need of urgent intervention. So I want to go back here for a moment. I forgot to mention something to you. At the building and district level, we ask a question 3 times a year for the elementary and benchmark assessments, 4 times a year at middle and high school during report card. Is this a healthy district, or is this a healthy school? And our definition of that is very concrete. If more kids are doing better on subsequent assessment windows, either improving or reaching proficiency, then it's a healthy school or it's a healthy district. If you have greater number of kids doing worse across time, it's an unhealthy school or an unhealthy district. So clearly, this district, that the slide that's on your screen, that's an unhealthy district for third grade reading. Kids get worse over time. It's unhealthy to be there. And that's sad, but it's true. Let's look at this second grade now for this district. Second grade reading, this is fall data. And by the way, proficiency is here, but improvement is moving from here to here, blue to green, yellow to blue, red to yellow. If you lower your level of risk, you're improving. So proficiency and improvement is what we look at. Here are the winter data. Well, you can just tell by looking at the two that more kids are in the green, fewer kids are in the red, yellow, etc. But let's make a graph out of it, a table out of it. So in the fall, we had 63% of the kids at or above proficiency. In the winter, it moved to 73%. On watch was 11% and 14%. That's a 3% increase, but that's okay because it shows improvement. So some of the kids that were at intervention or urgent intervention moved to on watch, and some of them moved to proficiency. So we had 13 kids improve in those categories, and you'll see that they went to proficiency and to on watch. So this is a healthy school. This is a healthy district. Increase in proficiency and lowering risk. So let's take these kind of data in a classroom. Is this a healthy classroom? What is the kid's response to instruction or intervention? We don't have to use numbers. We can just use colors. So a positive response to intervention is any time you're moving in a color in the direction of the green. Any time that you are moving in the direction of red, that's a poor response to intervention. And any time that you stay at a level, it's questionable. Because those of you who are familiar with these kind of data, and I'm sure all of you are, know that at the second assessment window, to stay in the same risk level, the expectation is higher, so you have to improve. The problem is you've improved enough to stay at that level, you haven't improved enough to close the gap. So what we see here is if you just look at the first column on the far left and look at the first and then the last column on the far right, what you will see is a lot of green on the right and a lot less green on the left. So is this effective instruction? At the end of the year, all but 2 students were proficient or above. The students in the red was a new student to the district mid-year. And that yellow strategic, we would ask for a reassessment on that because that's a student who had been proficient all year long. The probability is that it's an assessment issue and not the student. So for a student moving from, let's say in this case, from red, the bottom, red to yellow, that's a positive response to instruction. Yellow staying in the yellow, that's questionable. Yellow moving to the green, that's positive. If we were to go in the reverse, and we really don't have anybody here because the red student up here is a move-in, but let's say that they did go in that direction, that would be a poor response. So we can take one look at this and know which of our students are healthy. That second assessment window is often more variable than the first one because the first one kind of reflects what kids are supposed to know coming out of the previous grade level. In our health and wellness meetings, we identify students that we want to talk about, but we don't talk about them during the meeting. What we do is say, is this a healthy classroom or not? Who are we worried about? And then if we're going to look at individual students, we will do that later. But in this meeting, we'd say to the teacher, what about these 2 students here, these 3 students here that went from green to yellow? Are you worried about them? If the teacher says yes, then we problem solve those students in another meeting. If the teacher says no, they're improving, they just weren't improved enough to move back into the green, I'm going to monitor them more frequently, but I don't want to change anything for now. And then we respect that. And in this case, that teacher would have been right because you see that those kids ended up transitioning to the green. So red to yellow, positive. Yellow to green, positive. Staying in a color, questionable. Green to yellow, poor. Yellow to red, poor. So I am going to stop there because that's the last slide, and I apologize for taking so long. Do you have any burning questions at this point?
And Dr. Bashwell, a couple folks are
They're
typing. I'm going to post the survey.
Okay.
Thank you for your wonderful presentation today. We'll wait a couple minutes here for the folks to finish typing.
Didn't see any come up here.
No. Oh, there we go.
Okay. Good. Awesome, Deborah. That's awesome. And you can use that table, too, that table that I had to put in like your fall, winter, spring, and organize your data that way. Excellent. The issue about is it running 25 to 33% in math proficiency. I don't know if it's a core instruction issue, Sheila, but that is what we would problem solve first. So are we going to look at core first? Absolutely. Yes. And the one thing I would look at is the amount of time. If kids, as you know, math is spiraled, and some kids, particularly if they come in with poor background, they need more time. They don't have a learning disability necessarily. They simply need more exposure, more feedback, more correction. But I would go to Tier 1, yes. I'd problem solve it like we use the model today. 67% of our kids are not proficient in math because. I'm glad you liked it. Yeah, I would take a look at that. That sufficiency issue. And see if something you can do, Sheila, is you can also take a look at whether or not the proficiency rates of the kids in 5 and 6 drop in 7 and 8. Because if they were doing better in 5 and 6 with an hour every day, that's 300 minutes a week. Then they drop to 200 minutes a week. And if they drop then that's a one way to problem solve it. You know what I would do as a teacher? I would simply say, I wonder if the amount of time that they have math in 7 and 8 matters. Is there any way we can look at the students who look at the proficiency level of the students in 5 and 6 and compare it to 7 and 8? And maybe that'll tell us whether time is the real culprit here. And you wouldn't be throwing anybody under the bus. And you should have the data to do it. We'll wait for this. Sheila's typing one more thing, and then I'll let you go. Perfect. Awesome. Well, I'm glad this is relevant for you today. And thank you so much. I'm honored that you signed up for this and that you stayed. And have a great week. Thanks a lot.
Thank you, Dr. Bash, and we hope to see everybody back on November 15th for our fourth session. Have a good night, everybody.